Hello dear students, today I will discuss about fourth unit, finite difference and interpolation. Okay, interpolation with equal and unequal intervals. Okay, interpolation means, and extrapolation also there. Interpolation means, suppose we are giving given like this, values of x and values of y. Suppose for 1, 2, 3, 4, 5 and given values are there here, here, here and here, also 5 values are given. We are having this step, that is for x equals to 1 we have value this, for x equals to 2 we have this, and just we have this step only. So what will be the value for x equals to 2.5 or 1.5 or 4.5? That means in this range from 1 to 5, accept these points. If we want to find the value of y for 2.5, that is in between 2 and 3, 1.5 in between 1 and 2, means within this range, accept these values. If we want to find the value of y, then what process we will adopt? Interpolation. Finding this type of values for a dependent quantity, for a particular value of independent quantity within the range, inner part, called interpolation. Means finding the value of y for value of x which lies within the range, internal part of the range, inner part of the range, then that method is called interpolation. Also, suppose we are trying to find the value of y for x equals to 5.1, 5.2 or minus 0.5, or suppose 0.5. 0.5 is where? Outside this range. 1 from, this is start from 1. So outside range is what? 0.5. So for 0.5, what will be the value of y? For 5.5, what will be the value of y? For finding that type of value for a given data, the process will be called extrapolation. And interpolation, if the value of x is inner part of the range, given range of the value of x, and for that value, if we want to find the value of y by some process, that will be called interpolation. Okay, so this is interpolation and that is extrapolation. Okay, so here interpolation is the main thing. Here, if the values of independent variable are at an equal distance, maybe at an equal distance, maybe at unequal distance. So first of all, we are discussing about equal intervals for independent variables. Okay. So for interpolation and extrapolation of a value of dependent quantity, that is a value of function, just we use the concept of difference. Concept of difference. Difference of a function. Difference of a function. This difference. This is the concept of difference of a function. This is a new thing. Okay, just we have to now discuss about difference of function. By using this difference, we can get some formulas for finding values of y for the value of x which will lie inner part or outer part of the range of the values of x. There are many formulas. Just we have to discuss about 4-5 formula divided forward formula, backward formula, stealing formula, basis formula. All the formulas are depend on difference, and that formula are used for interpreting the values of functions. Whenever we have a table, not the format of function, because here also y is depend on x. Y is depend on x, but its values are tabulated. We are getting these values from an observations, from a practical observations. So we can get a table for values of x and y. So for a particular value of x within the range, finding the value of y dependent variable, which is the function, is known as interpolation. Interpolation on completely based on difference, concept of difference of functions. So first of all, here first 1-2 classes are required for discussing about difference. Okay, so there are different type of questions are there also involving differences. So here first of all, just we'll discuss about difference operator. How can we find the difference of a function? What says difference of a function? How can we find the differences, different order of differences of a function by using table? Just now we will discuss about it. Okay. So difference, finite difference. Clear? So just like differential calculus derivatives, here also we use difference of a function for finding values of functions. So first is forward difference. Forward difference. Difference. Second, backward difference. And central difference. Okay. Second and third. Backward, central, forward. These three type of differences. Okay. Their definitions very simple, because interpolation is very simple, because just we require formula and prepare the table, and from the table just put the different order of differences in the formula, then you can get the value. Okay, numerical maths completely. So here forward difference, backward difference and central difference. So first of all, we have to discuss forward difference. For forward difference, just we use this del forward operator. For backward difference, backward operator. Central difference, we use delta. Clear? So first of all, forward difference. Just we will discuss about forward difference. We know whenever x and y, we have a table. Maybe the values of x are at an equal intervals, at an equal distance. For that, suppose first value is x0, second value plus h, third, suppose interval is h, then third value will be x0 plus 2h, fourth value will be x0 plus 3h, and up to, suppose rth value, just like values of x may be like this, what, x0 plus r minus 1 h. Interval, that means first value x0, you can put x0 first value, just like this 1 2 3 4 5 and up to this, if x equals to this, at equal interval, what, 1 x0, 2 1 plus means h equals to 1, here h equals to what, 1. Okay, then you can put x equal to, x0 equal to 1, then 1, x0 equal to 1, then h equals to 1, here h equals to what, 1. Interval of differencing, interval, in which interval, equal interval, so here interval is h, clear? So h equals to, for this particular values, h equals to 1, because just you can see 1 plus 1 2, and 1 plus 2 into 1 3, 1 plus 3 into 1 4, so h equals to 1. So these values are given at equal interval of differencing as 1, starting from 1 x0, first value of x. Okay, so this type of interval we can say like this, clear? And value of y are denoted like this, corresponding values of y are denoting here x0 y0. Here notation is depend on just like this, x0 plus 0 into h, we can write like this. So this 0 is used for notation y0. Here x0 plus 1 into h, that is y1, x0 plus 2 into h, y2. That means this 0 1 2 are from where, 0 1 2 3 and so on. So this notation for what, y3, and like this is where y r minus 1. These r values are there because 1 to r minus 1 and this value is 1, r value. Okay, this will be the notation, and x is called argument and y is called entry, the value of the function. In other words, we can say the value of the function, entries. These are the entries. Okay, entries, and these are the arguments. Clear? Whenever we given a table x, the values of x and y are given, then this is equal interval. So here interval of differencing is h. Okay, so just this interval differencing. Clear? So this is the notation. Arguments means value of x, entries means value of y. Corresponding notation are like this. Now here difference of, just like derivative, here first order difference, second order difference, third order difference, all the differences can be found by its definition. Okay, so definition is very simple. Suppose we are having function, we say function y, that is fx or y. Okay, so suppose we are having function fx and first order forward difference is one, first order forward difference of this. We can write like this: y equals to what? fx. Also y can be written as a x. You can use any of the notation. Okay, so that is what? Del yx. You can write like this or this. First order forward difference is equals to, remember that forward difference just we like write like this: x plus h minus fx. H is interval of difference. Okay, also we can write y x plus h minus yx. Both are same. This y is function of x plus h, fx plus h. This is the definition, first order definition. Clear? Means here we see that y1. Suppose, for example, y1 and h is 1. Suppose y h equals to 1. Then what? X plus h means here we see that fx is subtracted, yx is subtracted. So here y1 is subtracted from which 1 time greater than, argument is 1 time greater than, 1 times of h is greater than. Means here if h equals to 1, then here will be what? 2. y2 minus 1, 1 greater, because h equals to 1. Also if h equals to, if h is h, then just y1 plus h. So for first forward difference says what? Here we see that y1 is subtracted, y1 is subtracted, yx or fx is subtracted, yx is subtracted from the value of function where argument is 1 time greater than interval of difference. This is the definition of first order forward difference. Okay, so remember it. And similarly, we can find second order difference, third order difference here, just like this. Suppose second order difference, yx, here at argument x. So here we second order means we can write this double times. Okay, like this. That is what? First of all, this is equals to yx plus h minus yx, and del is distributed. Just for our del operator is distributed. So we can write del yx plus h minus del yx. Now we can do its difference just like what? This means this, and this means this is subtracted from the value of function where argument is 1 time greater than this. That means what? yx plus 2h, 1 time greater than, minus yx plus h. Here this means this, yx plus h minus yx. So it can be written as x plus 2h minus both are same. So 2 times of y x plus h minus plus yx. This. So second order difference is this. Okay, here we can see that second order yx plus h, yx plus 2. For if we use the notation where number of times x, h, here we can write y2 minus 2 y1 plus y0 del 2 y0. This is a notation, okay, because yx means x plus 0 into h, y0 this is y1, this is y2. So this, when x in place of x we write 0. So del 2 y0 equals to this. This is the notation. Okay. Similarly, we can find third order difference, fourth order difference, fifth order difference. Here we see that first of all, here first difference, it can be also written if we write like this y0. If y0, then what? y1 minus y0. This is if h equals to 1. Use that notation. Okay, this. So first order difference, this. Second order difference, we see that y2 minus 2 y1 plus y0. Okay, second order difference. Similarly, third order difference, y0 equals to y3 minus, just like a binomial coefficients are there. Okay, minus 3 plus 3 and minus 4 plus 6 minus 3. Okay, y3 minus 3 y2 plus 3 y1 minus y0 it is here. Okay, similarly y4 minus 4 y3 plus 6 y2 minus 4 y1 plus y0. This is for del 4 y0. Just you can express it just like this. Del square means del into del. So this del q means what? Del q means del q equals to means what? Del into del. First of all, just put it value and then distribute it, then express and then express, you can get like this. Similarly, del power 4, fourth order difference, you can get. So here, from here we see that the coefficients are means differences of different order differences, forward differences, can be expressed in terms of entries. Just fourth order difference means y4, third order difference y3. Just you can see that 0, 1, 2, 3, 4, 0, 1, 2, 3, 0, 1, 2, 0, 1. Okay, so this is the finding differences of different order, we can see here. Okay, from here we see that differences are involving what? Coefficient of a binomial coefficient, just like binomial coefficient here. Means suppose we write nth difference of y0, nth difference of y what? 0. Then just like fourth difference, third difference, second difference, one difference. So fourth means fourth, 4, 4, 3, 3, 2, 2. So here y n. Start from y0. Start from what? y0. They are binomial coefficients. So 1 minus 1, and then what? 1 minus 2, 1, and then what? 1 minus 3 plus 3 minus 1, and then 1 minus 4 plus 6 minus 4, 1. These are the binomial coefficients. And sign are plus minus and plus minus. So we can write differences in terms of just like this, minus and c 0 and c1 y n minus 1 plus and c 2 y n minus 2. Okay, this type of formula we can get like this. And finally last term will be depend on n minus 1, just like n minus 2 by n minus 1, no? n and y 0. Okay, this NCN will be there. Also NCN means 1. Just you can write like this, NC and y 0. So nth difference of depending like this. Also, remember, suppose y0 equals to what? y1 minus y0. If y2 equals to 1 to write, then what? This is start from 0 in reverse order. So 0 and 1, y2 start from y2 minus y3. Suppose second order difference. We know second order difference. How we can write second order difference y0? y2 minus 2 times of y1 plus y0. Just like this. Second order difference. So if we want to write second order difference at 3 argument, then it will start from 3 here, y3 plus just 1 greater minus 2 y4 just y5 3 4 5 3 4 5. Okay, so writing method, different order of differences of function we can write like this. This forward difference. Okay, forward difference is like this: yx equals to yx plus h minus yx. This is the definition. H is interval of differencing. Interval of differencing, same interval. The values of function are at a same interval. Okay, now these differences can be found for a given data by preparing a table that is called forward difference table. That is very, very important, because table making is important. From table we can find all order of differences. Okay, so just see also the difference of this. Same difference, just like this here. Suppose del y0, first order difference, we write y1 minus y0. This difference is known as first order difference of function y at argument 0. Here backward difference are defined as just like this: yx is a similar pattern, just here, just like here, yx is subtracted. Here not yx is subtracted. Here from fx is subtracted its lower argumented value of function. That is, from fx subtracted fx minus h. Here yx is subtracted or fx is subtracted, but from its higher argumented value of the function. Here yx from yx is subtracted its lower argumented value of the function. Okay, like this. Means del yx is equals to from yx subtract like this. From yx minus h is subtracted. Clear? This is the backward differences. Just like this, it can be written as, this can be written as y1 minus y0. We can write like this. Only symbol is different. Here 0 is here 1 is here. But difference is same. Because from y1, y0 is subtracted. Clear? This is difference. Only backwards differences from at backward side. Okay, from table it will be very clear. So what will be the argument at this place? That is main thing. Okay. Similar, we can find second order difference, backward difference. This is backward difference. What? Del of y1. We can write del of what? Del y1 means this y1 minus y0. This is distributed del y1 minus del y0. Okay. Now you can solve it. What? Y from y1 y0 is subtracted. Here from y0 y minus 1 is subtracted. So we can write y1 minus 2y0 plus y minus 1. So here minus 1 0 1. So here start from starting 1, then 1 less than, 1 less than, just like this. Clear? In terms of h, in terms of differencing h, then we can write like this. Clear? So this is backward differences. Okay? So here index is, suffix is main thing. y1 from 1 start as decreasing. Here 0 in reverse order we can see from 0 just start to 0, 1, 2, 3, 4 increasing, and backward from start from 1 and then subtract and decreasing in as a how many times number of interval differencing. This is the backward differences. Clear? So same thing. This is also, this can be written as what? Backward differences of y1. This is forward difference of the same difference. This differences is forward differences of y0, backward differences of y1. Okay? Now, central difference is also same thing. Okay, but it is defined as central difference. Here backward difference is what? Yx means yx minus h. Clear? Central difference is, this is yx equals to yx plus half h minus yx minus half h. Okay? That means its average is this. See here, x plus half h, x minus half h. That means x plus half h plus x minus half h by 2. What? Plus half h minus half h cancel, 2x upon x, 2 cancel, its value is what? X. Average of these two argument. Average of these two argument, where first value is greater and second value is lower. Average of this. Okay? It is based on half. Here we can see that del y0 is equals to delta y half minus y minus half. If we use that notation, what? x0 plus 0 into h, x0 plus 1 into h, x0 plus 2 into h, x0 plus 3 into h, 1, y0, y1, y2, y3. If y1 means 1, y2 means 2, y3 means 3, here what? Half. So y half is this, y minus half is that. So this minus this means delta y0. So this is the notation for central difference. Okay? This difference can also be found from table. Okay? The three differences are very important. One formula from this difference, one formula, Newton's forward difference formula for interpolation related to this difference. Newton's backward interpolation formula related to this difference. Stirling and Bessel's formula based on these differences. These formulas we have to discuss in this unit. Okay. And also there are different difference and Lagrange's formula. They are for unequal intervals. Here equal intervals. Okay. So this here we can see this difference. This can be written as what? This. If we take y1 minus y0. Then we see that difference, for difference, this is average of these two. 1 plus 0, 1 plus 0 by 2, what? Half. That is delta y half equals to this. Delta y half equals to this, because 1 and 0, average of 1 and 0. 1 and 0, average of 1 and 0 is what? 1 plus 0 by 2, 1 by 2. So delta y half. This is equal to what? Also, it can be written as delta y half. At half index, central difference. F at y argument, backward difference. At 0 argument, forward difference. Difference is same. Okay? So only taking, how can we take differences? For these three formulas, these three type of differences are useful for making formula for interpolation, and that formula are very, very important. For using formula we can interpret the values of functions. Clear? So these three type of differences are there. Okay. Now in this unit there are these three type of differences are very, very useful. Okay. So operator, just forward operator, backward operator, central del operator, del operator. There are two operators are extra, shift operator and average operator. We will discuss about it sometimes later. Just first of all, see what is the meaning of preparing table, and from the table how can we find difference, backward difference, forward difference. Here main thing is that difference of function at argument, at which argument. Okay, so all type of differences, this is forward difference, backward difference, central difference, all three differences can be found from a single table. Very simple, just see its notation. Okay, so how can we make the table? Okay, so just understand what is the process of making its table and how can we find a particular difference from the table. Clear? So here value of x and value of y, value of x, okay, preparing the table for forward difference table, backward difference table, okay, value of x, value of y. Very simple. Table preparation is very simple. Okay, so just you have to write first of all fifth difference. Okay, 1, 2, 3, 4, 5. Fifth difference. Just we have to write value of x. Suppose on general notation x0, then what? x0 plus h, x0 plus 2h, x0 plus 3h, x0 plus 4h, x0 plus 5h. This is our values of x. Okay. Because for solving questions, you have to prepare always table. First, for forward, backward, or central difference, you just require the table. For finding differences of function at a particular arguments, suffixes are there. Just we can write this type of notation. Its corresponding value, just we write y1, y2, y3, y4, y5. It means totally this, but just we have to denote like this. Clear? y4 and y5. These are the values. Difference table making process is very simple, just very simple. You have to only subtract and write the value in between this. Just like this is first difference. First difference. Okay? First difference. First difference means first order difference. That is for forward. If we take forward difference, then this. Del y. Okay? So here just we have to write the difference like this. Clear? Del y. Here also second difference. Second difference means del to y. Nothing here, index. Index will be here. With suffixes. Okay. So third difference. Third difference. Del q y. For forward, for backward, you have to write here backward operator. For central difference, you have to write here central difference operator. Okay, delta. So here fourth difference. Fourth difference, del 4 y. For fifth difference, del 5 y. Clear? This difference can be found. Or difference table making is very simple. Just subtract previous term from add term from this. That is y1 minus y0. Means what? y1 minus y0. Just you have to subtract it only. So y1 and write in between this. In between. Okay. In between here, right? Here. What will be this difference? First difference of y. Here, if we subtract y1 minus y0, forward difference, that means what? y1 minus y0 equals to what? y0. We know this because y1 minus y0 means what? Del y0 equals to what? y1 minus y0. So this minus this, del y0. So y2 minus y1, what? y2 minus y1. We know y2 minus y1 means this. Forward operator, y1 is subtracted from 2. So y2 minus y1, y2 minus y1. This y2 minus y1 equals to what? First difference at 1. This is first difference also. This is first difference also. This is first difference, all the first differences. But at different arguments. So this will be del y1. Right? In between this. In between this here, right? Del y2. What? y3 minus y2. Just this minus this. Just subtract. this from this from this from this from this from this, and right, and in the right hand side. Y4 minus Y3. Y4 minus Y3 means what? Del Y3. Y5 minus Y4 means what? Y5 minus Y4 means del Y4. So these are all the first order difference. First order difference of Y. This is on 0 index, this is 1 index, this is 2, this is 3, this is 4. Okay? Now, this minus this. What? Del 2 y 0. Del 2. Just write in between. Del y 1. Del square y 2. Del square y 3. You can see from here that del y1 minus del y0 means del 2y at 0. Del y2 minus del y1 means it's again difference. Means what? Del y2 minus del y1. Del y2 minus del y1 means del 2 y1, del 2 y1. Similar. This minus this means this. This minus this means this. So this is second order difference. How can you find it? Just subtract this from this. This from this. This from this. This from this. You can write like this. Okay. Whatever be the value here, just subtract this from here. This from here. This from here. This from here. And write in between this. So these are the second difference. Add index like this. Similarly, third difference. This in between this. This minus this gives third difference y at 0. You can see. This minus this, third difference at y 1. Forward difference. This minus this, y 2. Third difference at y 2 index. Just for fourth difference, this minus this. This minus this. Del 4th y 0, or this minus this del 4th y 1, and this minus this is del 5th y 0. So you can make this type of table. Just triangular format. Okay. So here we can see that for a particular values of data, values of a given data, we can make table and get forward differences of different order very easily. Yes. Okay. Just difference it. This minus this equal to this minus this equal to this minus this equal to this. This means this position will give first order differences at different index. Here we can see that. In this table, this is for forward differences. Okay. So here we can say that 0, here is 0, 0, 0, 0, 0. In this line from starting first difference, all the differences, higher order differences, first, second, third, fourth, fifth order differences, these are the leading differences, and this is leading term. Called what? Leading term. This is, and this, and this, and this, and this, and this. Leading means for forward difference formula, these differences are useful. These differences are used. That's why these are leading differences. When this is first argument of origin argument, you can also see. Okay, so if this is origin argument or first argument, then this is first entry leading term, called leading term also. Called leading term. Okay, this is called leading term. And these are the leading differences. These are the what? leading differences. Leading differences. Yes. If this is first argument or this is our origin argument, then this will be the leading term, and at this argument all the leading differences are used in form. Okay, if we take this as, suppose for example, if we take this or this as first argument or origin argument, then it will be leading term, and these differences will be leading differences. You can see here also, what? Here white 2, 2, 2, 2, 2. So these will be the leading differences. This will be the leading term if we take it as origin argument. Clear? So from this difference table making is very simple. Just write the value of x and value of y and just subtract and write the values. This minus this here, this minus this here, and just this minus this here, this minus this here, and just write up to last term. Okay. So this is forward difference table. From this we can see that for a given data we can just find all the differences by making table. Clear? Same table for backward difference, for central difference. Since all are same but notation are different, their argumented notation are different. Here we see that 0, 1, 2, 3, 4. Okay. So whenever we use, just try to understand for backward difference. Okay. This is forward. Now just we take for backward difference table. Just we know what is okay. So this was the table for forward difference. For making backward differences table making technique is same. Notation will be different, because here in between this we write what? Forward del y0. We know forward del y0 means what? y1 minus y0, but it is also denoted by backward del at y1. Its argument is changed, so del y0. But if we use backward difference notation, then y1 minus y0 means what? Backward del y1. Index will be changed. Same. y2 minus y1. That means what? Backward difference y2 in between this. Here y3 minus y2 means what? y3. Here y4 minus y3 means what? Backward difference y4. Clear? Here backward difference y5 minus y4. So this is same. Difference is means this minus this is this minus this is this minus this is this. Table creation Very simple. Just same process. But notation, this value will be what? Del, backward del y1. In the previous time, it was what? 0 notation. So here, first backward differences are there. Just see what? At the previous time, start from 0 to 4. Here, start from 5 to 1. Now, start from 5 to 2. And this will be what? Notation. Table creation method is same. This minus this equal to 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 this. But there was totally line is depend on y0. But here we see that indexes are difference, y1, y2. But in lower part, in backward side, from the backward side of the series, we see that 5. Just same. Here notation is from 5, 4, 3. 5, 4, 3 backward difference. You can see here. This minus this is this minus this is this minus this is this. Means whatever be the value here, just you have to subtract this from this right here. That will represent backward del q y3. So these are the second differences, third differences, fourth differences, 5 differences. You can write. Okay. So just here 5 and 4 and backward del. Here 5 and backward del. So here we see that in the case of backward difference table, this is origin and this will be the leading term and these are the differences at y5. Same 5, y5. These will be the leading differences for backward difference table. Clear? So table creation method is same. Only notations are changed for backward differences. For this argument. These are the arguments. So these are the backward difference table. As a similar manner, you can find also central difference table. Just table creation method is completely same. So here for central difference table, just see for central difference table creation method is what? Or just subtract previous term from ahead term. Okay. Following term. You can also say following term. Okay. For central difference. Central difference. Table creation methods. y0, y1, y2, y3, y4, y5. Table creation method is what? Or just subtract y1 minus y0. This is y1 minus y0 and y2 minus y1. Whatever be the value is here, this minus this is there, and also this minus this is there, this minus this is there. This is the process of making table. So here we see that y1 minus y0 means what? Y half. Because this minus this means 1 and 0, average 1 plus 0 by 2, half, delta y half. Here first order difference y, 2 and 1, 3 by 2. So here 3 by 2. 2 and 1, 3, 3 by 2, 3 by 2. So here y3 minus y2 means also delta y 5 by 2. Here delta 7 by 2. Here delta 9 by 2. Y, sorry, this is not 7 by 2 and y 9 by 2. Half index, first order difference, because this minus this, so you can see these are the first center differences. The notation are what? Here 0, then half. Just now subtract this from this. You can write here also. Here delta y 3 by 2 and delta y 1 by 2. 1 by 2, 3 by 2, 5 by 2, 7 by 2, 9 by 2. Just this minus this, and we know this is average of these two is here. So here this minus this is delta. Now average of this half and 3 by 2. 2 by 2, 1. Second order difference y1. Second order difference y2. Second order difference y3. Second order difference y4. You can see 5 by 2, 3 by 2. 5 by 2, 3 by 2, 8 by 2, 4, 4 by 2, 2, 2, 5 by 2, 7 by 2, 5, 7, 12 by 2, 6, 6 by 2, 3, 3, 9, 7, 16 by 2, 8, 8 by 2, 4, 4. So this minus this minus this minus this, just you have to write, and this will be the notation for that difference. Here, delta q, y, 2 and 1, average 3 by 2. 2 and 1, 1 plus 2, 3, 3 by 2. So delta q, y 3 by 2. So this minus this, 3 plus 2, 5 by 2. Delta q, y 5 by 2. Delta q, y 7 by 2. Just average of this. Now average of these two. Here, 4. 5 by 2, 3 by 2. 5, 3, 8, 8 by 2. 8 by 2 means 4 by 2. 8 by 2 means 4. 4 by 2, 2, 2. This will be 2. Here also 7 and 5, 12, 12 by 2, 6, 6 by 2, 3, 3. Delta or 4, y 3. And here delta 5 in between. 5. 5. 3. This minus this. 3 plus 2, 5. 5 by 2. Y 5 by 2. Okay. So this is center difference table. Just make it. This is the index. Index is the main thing. The second difference is integrals. Fourth difference, integral. That means even order differences having suffixes as argument, integral values, and half values are first order differences. So this is for central difference related formula, values are used from central side. That its central line is what? 3, 3. Central line is here. You can see central line is this value, and then this value, and then this value. This central line. And stealing formula, basis formula, they are given just like a central, then down, then up, then down, then up, then down. Central and stealing and basis formula depending on this difference. And just like central difference formula, just central difference is there here. If we take this is origin argument, then from here we can start. Or if this is origin argument, then we can start here. This is 5 by 2, this is 5 by 2, this is 5 by 2, same. all the horizontal lines gives suffixes same 5 by 2, 5 by 2, 5 by 2. Here also we see that in this line, here y2, 2, here in this line 3, 3, in this line 7 by 2, 7 by 2, in this line 4, 9 by 2. Here we see that 3 by 2, 3 by 2, this line. Clear? So table creation method is same. Just subtract y0 from y1 right here, y1 from y2 right here. Also subtract this from this right here, this from this right here, and just make the table. And notation for the differences just you take from table. Okay. So this three table preparation for these three differences are very, very important. Okay. So here now take first of all here we see that if a function is a polynomial, then how can we define the difference of the polynomial based on degree? Suppose here difference of a polynomial, just our topic now. I will discuss about topic just like not other operators. I will discuss in the next class for other operators. Okay, here see difference of a polynomial. Difference of a polynomial. Polynomial. Difference of a polynomial. Okay, difference of a polynomial. See here, one thing is very, very important for this. Difference of a polynomial. Okay, suppose difference of polynomial means generally we are discussing about function. Function may be as a polynomial. Clear? So suppose we are having a polynomial of which degree? We know the first degree, second degree, third degree, fourth degree, fifth degree, maybe the degree of polynomial. So suppose we are having nth degree polynomial. So we can write a x to the power n, b x to the power n minus 1, c x to the power n minus 2, and so on up to k x to the power 0. Clear? And a degree polynomial we can write like this. Okay. So difference of this function means fx function as a polynomial. So we can differentiate it. Just put here ax to the power n plus up to k here. What if we take difference, if we take interval of difference in each edge, because at equal interval. So suppose this is value, so we can write now what difference of function fx plus h minus fx. This is the definition. Del fx equal to fx is subtracted from x plus h, that is fx equals to this, that is this, in place of x we have to write x plus h. So a x plus h to the power n, b x plus h to the power n minus 1, and so on up to last term here x plus h into L, suppose any number, and then k. This type of value will be the first. Means just we use this formula fx plus h. This is fx. in place of x plus h, up to here, its last term x to the power 0, and its previous term, what? Some constant into what? Some constant into x plus h to the power 1. So, x plus h to the power, no, sorry, Lx plus k, last term x and then 0 term. So here L x plus h, this minus of fx total, ax power n, bx power n minus 1 plus up to Lx plus k. Just we can differentiate it. Now here we can see that ax to the power n, ax plus h to the power n, just binomially expanded, then first value will be x to the power n. A into x to the power n, a into x to the power n will be cancelled out, and second term will be x to the power n minus 1. So it will be a polynomial of a is this, and x to the power n minus 1 and a polynomial of degree n minus 1. We get like this, na? Also here n, n comes what? Why? Because x to the power n plus nc0, nc1, binomial expansion. nc1 means nx to the power n minus 1. So n will common. So an and a polynomial of degree n minus 1. 1 degree less. First difference. First difference of polynomial. A into n, first term a, and then n and a polynomial. A polynomial of, or we can write like this, polynomial of degree n minus 1. Just repeat this process, then we can get a n minus 1 and polynomial of degree n minus 2. Okay, second difference. Similarly, nth difference. Then a 2 times 1, n times n minus 1 means finish. So a n minus 1 up to 1. Okay, and also here h will be here also. So a n and h a n 1 time h, 2 time h square, and here n times h to the power n. This is equals to a n h to the power n factorial. Because 1, 2, 3, 4 up to n factorial. H first time, 1 time h, second time, 2 times h, third term, h to the power n. You can see it by doing. Okay, because after 1 time we get like this, then again do 1 time h, 1 time n minus 1 and h cube, n minus 1, n minus 2 and so on up to nth time. Just we can get from 1 to n, h to the power n. So nth difference is this. So from here we see that nth difference, what? Nth difference of a polynomial of a polynomial Pnx is constant. Constant. This constant means no terms related to x. A h to the power n factorial. This is a constant. So nth difference of fx of nth degree polynomial. Nth difference, nth order difference of a nth degree polynomial is a constant always. Nth order difference of a polynomial of nth degree is constant. Clear? Now, if we take higher order differences, n plus 1, want a more difference yet, then this is equals to 0. Because difference means fx plus h, we can see that this is constant, the constant minus constant, 0. So, nth higher order differences are 0. Means nth order forward difference of a polynomial of nth degree is always constant and its higher order differences are always 0. Note down it, okay? So this is difference of a polynomial. Okay, nth difference of a polynomial of nth degree is 0. Constant, and higher order differences are 0. Clear? So, by taking its concept, and also here one thing, just note down that if we are given 3 entries, if we are given 3 entries, 1, 2, 3, then we can get first difference, second difference, and this is first difference, this is second difference. Second difference will be constant. That is, if we are given 3 entries, because just we are given these 3 entries, then we can take first difference, second difference, this minus this minus this is this first difference, and also second difference this. Okay, third difference will be 0. This will be single value. So here we see that if we are given 3 arguments, then second difference is constant. That is second. If we are given 3 entries, then we can we can approximate the function as a second degree polynomial. If we are given 3 entries. If we are given 3 entries, then we can suppose the function is a polynomial of second degree. If we are given 4 entries, then this first difference, this second difference, this third difference, and fourth are 0. So if we are given 4 entries, then we can approximate the function as a third degree polynomial, constant. Clear? So, by taking this concept, just solve a question. Okay? So, take a question. Find the missing values in the following table. Find the missing value in the following table. Okay? So, table is 45, 50, 55, 60, 65, the values of x. So just we are making table for these questions. We have to find the missing value. Well, how many missing values are there? 2. Okay. So here write the value of x, value of y. Clear? So here how many values are arguments are there? 5. So take first difference. second difference. And third difference. Clear? For these questions, just we have to make the table. Okay, 45, 50, 60, 55, 45, 50, 55, 60, 65. 45, 50, 55, 60, 65. Okay, so just make table. Table is like this: 45, 50, 55, 60, 65, like this. Clear? And value of y is 3.0, 2.0, minus 2.4. 3, 0.0, 2. No, this is dash, nothing is here. 2.0 and minus 2.4 is this, na? Minus 2.4, 2.0, 50 and 60 are not given. Here not given. So we can prepare this table, and from here just see that this is x0, then it is will be what? y0. This is y1. This is y2. This is y3. This is y4. This will be the notation. Okay. Here, just how many entries are given? 1, 2, 3 entries are given. So function can be represented or can be approximated by a polynomial of degree 2. If third 3 entries are given, then we can approximate the function as a second degree polynomial. Clear? That is second degree, up to second degree differences will be constant, third differences will be 0. Clear? Here 3 entries are given. 3 entries are given means third difference will be constant, that is, and second degree polynomial can be supposed for the function. So second degree polynomial for second difference will be constant. We know third 3 entries are given, the second degree polynomial can be supposed, and higher difference third differences will be 0 and second difference will be constant. So here y1 minus difference, y1 minus y0, this is y1 minus 3, and here 2 minus y1, here y3 minus 2, here y4 minus means minus 2.4 minus y3, and second difference, this minus this, 2 minus y1 minus this minus this, so 2 minus y1 minus y1 2 minus y1 minus y1 minus 3, so what? 2 minus 2y1 plus 3, so 2 minus 2y1 plus 3, 2 minus 2y1 plus 3, here this minus this, so y3 minus y3 minus 2 plus y1. Here this minus this, so minus 2.4 minus y3 minus 2y3 plus 2. Clear? And this minus this minus this means it can be written like this, 3 and 2 5 minus 2 1, 5 minus 2y1, 5 minus 2y1, 5 minus 2y1. So this minus this, so y3, just you can see here, y3 minus 2 plus y1 minus 5 plus 2y1. So y2 y1 2y1 plus 3y1 and minus 5 minus 2 minus 7 and y3 plus 3y1 y3 plus 3y1 minus 7. Okay, there this comes from where? Just like this. See, this minus this equal to this minus this equals to minus 2.4 minus 2y3 plus 2 is also 2 minus 2.4 means 2 minus 2.4 minus, here you can write minus 0.4. So minus 0.4 minus this y3 plus 2 minus y1. So here we can write y3 minus 3y3 and 2 minus 0.4. 2 minus 0.4. 0.4 means 1.6. So 1.6 minus this minus y1. 1.6 minus 3y3 minus y1. Clear? Yes. 1.6 minus 3y3 minus y1. So this is the table, but table creation simple. This minus this is, this minus this is, this minus this is, this minus this is, this minus this is. Okay, table creation. Now 3y1 plus y3, 3y1 plus here y3 minus 2 minus 2 plus y1. So minus 4 is there, no? Minus 4. If minus 4 is there, then just y3 minus 4 plus y1 minus 5 minus plus 2y1. So 9 minus 9. y3 minus 9 plus 2y1. y3 minus 9 plus 3y1. Just minus 9 is this. Okay. This minus this is this. Minus 9 and 3. This. And this minus this means here minus 4. So minus 4 means 4 minus 3.6. 3.6. 3.6. Okay. 3.6 minus y1 minus 3y3. These are the differences. Okay. Just as usual, this minus this, this minus this, this minus this, this minus this. Okay. This minus this, this minus this, this minus this, and this. This minus this, this minus this. Now, since we are given, how many entries are given? 1, 2, 3. 3 entries are given. That is, we can approximate function as a second degree polynomial. That is, second degree differences are constant. That second degree differences are constant, and third differences will be 0. Third differences will be 0. That is, this is 0, this is 0. Since only 3 entries are given, since only 3 entries are given, so function can be approximated or represented as a second degree, just one less, second degree polynomial. Second degree polynomial. Therefore, if second degree polynomial, then third difference will be 0. So, third differences will be 0. That is, third difference y0. Third difference y0 equals to 0. Also, third difference this y1 equals to 0. This is equals to 0. This is equals to 0. Clear? Now, from here we can, this means what? Third differences are y0, y1, y2, y3, y4, all are 0. That is, third difference, this is 0, this is, so implies, or therefore, we can write y3 plus 3y1 minus 9 equals to 0, and (3.6) minus 3y3 minus y1 equals to 0. Now we can solve it, because y1, y3 linear equations are there. So we get 2 linear equation in y1 and y3, which can be solved. Here 3y1 plus y3 equals to 9, and y1 plus 3y3 equals to 3.6. On solving, we get y1 and y3. Okay, so here we see that 3y1 y3 equals to 9 and y1 plus y3 3 equals to 3.6. On solving, y1 2.925, 2.925, and y2, y3 0.225, 0.225. Just you can use calculator. Two linear equation you can solve it by eliminating, and on solving we get y1 equal to this, y2 equal to this. So this is missing term, y1 and y3 are given. So by using this, that is main thing is what? 3 entries are given. So function can be approximated as a second degree polynomial. The third difference will be 0. That is, this is the third difference both. So both will be 0. So take both are 0. So we get two linear equation can be solved, and this is the solution. 2.925, 2.925 and 0.225 y3 y1. Okay. So this is the technique for finding missing terms in a given table. Okay. Now, one questions for your attendance. Okay. Just do it and send me for your attendance. Question. Here, just 5 entries are given, and remaining just 3 entries are missing. So 5 entries are given means what? Since only 5 entries are given, so we can approximate it. Function can be approximated or represented as a 4th degree polynomial. That is, 5th difference will be 0. 5th differences will be 0, and also we can suppose that after making table we can see what will be the position are there. Okay, so here just given here values are given, just like 5 entries are given, that is we can approximate it as a 4 degree polynomial. If 4 degree polynomial, then 4 degree differences will be constant. So make the table x, then y, and then table. Now first, second, third, fourth, fifth differences. Just you can see here value given as not. Just y0, y1, 2, 3, 4, y5, y6, y7. Just we are finding this value, y7. Okay. Finally, we have to find the value of y5, y6, y7. Just prepare the table. This one is this one is this. Just prepare the table. And 4 difference you can see here 16, then 16. 4 difference will be constant. That is, all the differences should be 16. So here just use notation. And this is equals to this minus this. Here we may be notation, maybe particular value. So this is equals to this minus this. This can be fine. Similarly, this can be fine. This can be fine. This can be fine. This can be fine. You can just come to here. Then you can get y5, y6, y7. Okay. So this will be the technique for this solving these questions. Just there are 5 entries are given and 3 entries are not given. Just you have to find y5, 6, 7. Just use this 4 difference are constant, 1 constant, then all are constants. Then this constant is equals to this minus this. So this is 16, this is particular value, suppose this is difference in notation. So this minus this equals to this. So you can find its value because both are known. So on getting this value, then you can just also here notation. So this value is also obtained. So these two are known. So you can get this value. So you can go to here up to finding differences. So finally you can get y5, y6, y7. Just refer the book and also do it. Okay, missing value problem, and send me for your attendance. Okay.